Okay, I've been tracing these wires. This wire here is the power coming in. It goes to the switch, which is not working, comes back from the switch, connects to this bundle here, which would be the neutral bundle. There's a wire that comes from it there, goes down under there, the bottom wire. I don't know if you can see the bottom wire, but it's to the, there it is, down there. It comes around here. There's two wires together here, one on top of the other. The bottom wire is the neutral. Comes around here, and it comes to here. It connects here, and then it goes to the, it looks like it goes through here, through there, that hole in the chassis down there. Right there, into that capacitor. The other end of the power comes here to the rectifier and to this capacitor, the top capacitor, which goes, it looks like that bundle is connected together. There. And all three of those, there's a little one down there, all three of those connect to here, which would probably be the B plus since it's red. And it connects here. Comes from here to here, and it goes around to, it looks like it connects to this output transformer here. So right now I'm just sort of documenting all of the wires and where they go. There's a slow scan. Try to help identify where these wires go in the future. Okay, and we got wires all over the place. Okay, so now we got to figure out where to put this diode, and I'm thinking across here somewhere. This diode has, well, this wire connecting to it and that wire connecting to it. That wire there. That wire goes to here, to the B plus. And I believe so anyway. Yeah, that would be that pin of the diode. And this pin of the diode, looks like it comes right off the power through this resistor and goes to these this top capacitor. So how that tube gets its voltage, I don't know. And when it emits, I'm assuming it emits to this, comes up through, it looks like it'd come through there to get to be positive, and this would be positive side of the rectified. So both of these would be, this would be a rectified return. This is AC. So I don't understand. I guess that capacitor, that's AC to that capacitor, and it's rectified across the power supply. Why that connects here back down to there is beyond me. You would think that the AC would go, well, yeah, I guess that's the diode from here to here. So we might have a cathode and output would be positive. I need to find the schematics on this tube. Okay, I started going through this radio, getting ready to put the diodes in to bypass the rectifier. And I figured I better check the tubes first. I'm seeing some stuff that doesn't make much sense. This line cord that's in here, you see that's been resoldered not too long back. It's clean solder joints. See how shiny they are? Let me get some light on them. Shiny they are compared to most of the duller, more original. See, there's a whole big solder joint there, and you see how it's not shiny like that. Those are all original solder joints everywhere. So I figured I better check the tubes first. So I'm going to show you what I'm finding if my phone will do this for you. I'm going to flip this around so that I can, I'm going to flip the view around so that I can stand this phone up and use two hands, but I need it close to what I'm showing you, so I'll be right back. Okay, I'm hoping that my camera will focus on this. Do you see those? Let me see if I can get my camera to focus first. Okay, there you go. Do you see those two wires in the middle that are busted? Broken right off there. And see it's burnt through. Wish this camera would focus better. And you can probably see them really good there. See them? That's the filament. That's the heater. And I traced one of those, let's see. I traced the wire on the heater string, and the first one came to here, where this X is. This is, we're talking old. I mean, these tubes are just really old. This is a 38. It says 38 on the top there. Right there, 38. So, anyway, this filament is shot. This tube is shot. This was the first tube after the rectifier. The rectifier tube, let me show you that one. This is the rectifier tube here. And you'll notice that the wires up in there don't look broken. See that hair wire in there? There's two of them. See them going up? They look okay. However, if you look at the plate here, you can see this wire going up, how burnt it is. Let's see if I can get that light to cooperate there so it's not so bright. See that? How burnt that wire is there. It got really hot. And look at the base of the one on this side. So this is the rectifier that's bad. Though those little hair wires didn't let go, something let go in this tube, and the heater element is not registering. If you look down here, you can see it looks like this thing crashed somehow or other. And it made this spot on the lens. So anyway, I started with the rectifier. This is a series string tube. That means that this, all of the filaments goes in one tube, pin of one tube, comes out another pin, in this case these big pins, comes out the other pin, goes around, goes to the pin of this tube, which is the one with the broken wire, and it would, if the wires weren't broken, it'd go in one and come out the other, and it would go to the next tube. Well, I haven't checked the next tube yet, but we'll do that now. I'm going to plug this one back in just so I don't forget where these tubes go. So we're going to need a few tubes. That's the 38. The next tube is this 36. I'll take it out. Let's see what condition it's in. I think whoever put that power cord in and did that soldering really messed something up. So I'm gonna just, oh yes, this one's blown too. Get the light back over there. And on that, shine in that tube there. Okay. Apologize for it taking time for me to get things set up. See, it looks like that wire in there is burnt off there. Now that, yeah. I don't know. Maybe not. Maybe not. Let's see if we can figure out where the filament is on this one. This is a Kenrad tube. Let's see if we can find it. With the meter here. I'll put the meter over here so you can probably see it. Right. If we can find the filament. Let me put this on beep. Hold on. There. Okay. Should hear that beep if we hit it. I mean, I could pull up the tube chart, but it's just as easy. What I'm doing here is just touching 2 pins at a time and going around and eliminating them as I go. There it is. So this tube's fine. This filament is fine. So this tube's okay. This 36 or 38, 36. This tube's okay. As far as the filament, the tube tests good. So we'll set that one there. Let's try the last one. And get it out of here. I just wanted to make sure we're okay before we, you can't see in this tube, it's really dark in there, so there's no way we can see if the filament is burnt loose. I see some wire in there, but I can't tell if it's connected or disconnected, so we'll do the same approach. We'll go around the pins and try to find it. That was me hitting the probes together. There it is. So this tube, the filament tests good. So 2 of the tubes, the filament tests good. 2 of the tubes are definitely blown. This tube was probably, this is the rectifier, so it's bad. And the other tube that has the bad filament, let's see, that is the 38. This 38. It was probably blown by the rectifier because it's the next one in line. So this one was burnt up because something's wrong in the wiring, and it burnt this one up. So there's 2 tubes that are not working. And I'm going to go around this one more time and make sure we don't get a beep. So if I do get it right, it will beep like this. So let's go around. Nothing there, nothing there. That was me accidentally. Nothing there, nothing there. Go to the next pin. Nothing there. Nope, again, that was me slipping off the pin. Nothing there, nothing there, nothing there. Next pin. Nothing there, nothing there. And we already tested these 2. And the last one, nothing, nothing, nothing. So this tube is shot, which I know because you could see the wires are disconnected in the tube. So 2 tubes out. 1 tube is a rectifier, which is the one we're going to replace. The other tube is a 38. So I would have to check and see if I can find the 38 for it. All right, so back to the radio. Let me shrink this down, okay. Like I said, these solder joints are not that great. This is the socket with the rectifier here. There's also some other issues. this resistor here, which I'm going to show you now. If I clip some leads to it, I clip one down there to the bottom end and clip one to the top of this resistor here, right there. Make sure I get a good connection on it, okay? And then if I put these on my probes, just so I don't have to hold the probes in those difficult to get spots, okay? We see we have around 7 megs, and it's counting up because it's across a capacitor. So it's 7 million ohms, basically. What the schematic is showing, it's this one, 135 ohms, that's going down to the rectifier pin, the plate of the rectifier. What we're getting is capacitance, or a very bad connection in that resistor, more likely, because the tube's out. So we're checking the bottom of the resistor and the top of the resistor. There's nothing on the bottom of the resistor because the tube's out. So it's just a socket. So if we go back to the socket and I take the wires off, this is the top of the resistor. The bottom of the resistor goes down there to the tube socket. And this, you can see the light right through it. There's no tube plugged in. So this is registering 7 megs, and it's supposed to be 7 million ohms, and it's supposed to be 135 ohms. That got totally fried in the same process. Now bear in mind that this has a wire going right to the power cord, okay? Now if we look at this resistor, which is the next one, the next tube that was bad, on that resistor, if we go from the bottom here, if I can get in there, tight squeeze, but we'll get it. Okay, we're connected there, and we connect to the top here. We're getting roughly, well, it's charging a capacitor. There's no tube in that socket either, but there is a wire connected to the bottom end. See that wire down there? And that wire wraps around to this tube socket. Then it has this black wire that goes to that capacitor, and basically it comes back around and connects up here somewhere through capacitors and a couple tubes. So it's counting up. So you see, we're just basically charging a capacitor. So if I disconnect it and connect it back on there, we're at megohms because the capacitor is charged up. So that resistor is not conducting through itself. It's going around the circuit and coming back with megohms of resistance, and it should be a short right to the 38 tube. So if we come back to the schematic on the 38 tube, this is the resistor I'm across. It's 1500. It's completely open. So we're putting a wire here, or on this point, and on this point, on both sides of the resistor. And what we're getting, since this is like a switch that's shut off, we're not getting 1500. We're going around through this capacitor, charging this 5 microfarad capacitor and coming back here. And we just charged that capacitor to the point where there's now megohms of resistance through that capacitor. And I can verify that, see we're at 2.3 megs, by simply switching the wires. Actually, I can do it on my probes. If I switch the wires, we know it holds a charge, because see, I can disconnect it. That goes down to nothing. Put it back on, and it's still at megohms of resistance. So, if I switch the wires on my probes, I might have just charged it, I don't know. But if not, this will be real low. Yeah, see, and it'll work its way up, back up into the megohms. Now we're charging the resistor the other way. the capacitor. So that resistor is short. That's 2 power resistors short. Now the next power resistor like that, there's no more on the tubes that I can see. It's just those 2. The next one is up here on the volume control. And if I go across that one, I'm getting 200 ohms exactly. Notice how it's not changing. We're not going through a capacitor. We're actually going directly through that resistor, and it's showing up as 200 ohms in circuit, which means it's still connected to other things, and but it's not going through all of that. It might be going some of it through that, but the majority is going through the resistor, 203 ohms. If we come here, that's the resistor on the volume control, and that's it right there, and it's 150 ohms. So it's probably about 175, maybe 200, because it drifted with age. But it's also got a capacitor. Like I said, it's got other parts of the circuit. The tube is in it. It's got this other tuning capacitor and this coil, and going around to the bottom here and back through the volume control to the other side. So it's probably picking up about 100 ohms through that stuff. What we could do with 200, it's supposed to be 150. No, actually, that's the resistor. Okay, we're not getting nothing through the circuit, because I just turned this 200K volume control way up and stayed the same. So this 150 is now registering 203. It's bad, but it's a resistor, it's doing its job. The other 2, like it, those 2 are blown out, and those 2 tubes are blown out. So power supply issues big time on this unit. What else can we look at? Well, we can look at, put that back on. We can look at the actual power resistor itself, which is this big resistor that goes across here, across the back of the radio. And it's this one here. If I can get in there. Okay, I got it. No, something's not right. That can't be that bad. Oh, maybe it is. Oh, geez. Let me try to get in there. Maybe I'm not on it. It's kind of hard because the coil's in the way there. But that's the terminal there. It's gone. It's toast. That's sad. That's the main resistor across the back. And it's shot too. And checking my wires on my probes. It's showing megohms. And it shouldn't be showing megohms. It's just the power resistor across the back there. Well, now we know why the diodes messed up, so I'm not going to be able to do nothing with this radio. Yeah, whoever put this line cord in here and redid this, they really hurt this radio. It's a shame because it's a desirable radio. No, I'm not getting nothing but megohms. Resistors open, we're going through other circuits. That's this 310 ohm resistor, which would make sense that it got fried because these are the filaments that we were looking at. The one in the diode here is in the rectifier. We know it's short because we can't get a signal on it. The one in the 38, which is the next tube in the line here from the resistor, this goes around. You see it comes back up. It goes filament of every single tube. It's the heater or filament, whatever you want to call it, and then it goes back to the rectifier. It burnt on this end. It burnt this resistor. It burnt this heater element, which is inside that tube where we can see the broken wires earlier. So, and also this resistor opened, and yeah, and that resistor opened. Both of those resistors, that 1500 and that 135, opened. So I could rebuild the system. I don't know where to find this power resistor. That's a problem. It's a 300 ohm resistor. I could probably rebuild that with something that, a Zener diode or something, a voltage regulator circuit, so that I don't overpower these. I have to find out what voltage these are because they're in series. The reason it has this big resistor here across the back of the radio, which is very low ohms, but it's a power resistor, is because you see how it goes through the switch, goes right through the filaments of every single tube, comes around filament, filament, down around filament of the rectifier and back to the plug. So that's directly across the plug is all those filaments. They have to add up to, in this case, the radio was rated 110 volts. They had to add up to 110 volts. So you have a voltage drop on this heater, you have a voltage drop on this one, another one here, based on the value of the tubes. They each have their own voltage rating. And whatever's left, it falls short. It's probably 80 volts or 75 volts or 93 volts. We don't know what it is because we don't know what these tubes values are. But whatever it is, in order to get it to 110, they put this power resistor in, and the voltage across it, the voltage drop across it, adds up to all these others and comes out to be 110 volts, and that's the way that works. Well, this is our power resistor, and it's a big one. It's supposed to be 300 ohms, and it gets really hot. So it's embedded in this metal case with asbestos around it to keep it, to chill it out. And it had this screen, which you can see it actually melted off the solder joints. It got so hot before it burnt out, obviously. This thing drew a lot of current. It was like a dead short. And so it fried. When it fried, the tube fried, that tube fried, these two resistors fried, and who knows what other effect it had on anything else. But that's where we are with this poor little Kadette radio. I'm seriously thinking of trying to find a way to rebuild this circuit. I'll put a circuit in this radio that'll handle the voltage and power requirements. Anyway, thanks for watching the video. If I repair this, I will make a follow-up video.